When we're dealing with gases, we've got the pressure, the volume, and the temperature, right? We studied how those are interacting with each other. If we decrease the volume of a gas, we've got the same temperature, we've got the same amount of gas, that will cause an increase in the pressure. It kind of makes sense when you think about it. You take a gas sample and you make it smaller, the pressure is going to be larger, right? If we increase the volume, if we pull that container out, the gas will expand to fill it and its pressure will go down. Okay? What if we're changing the amount of moles of gas? Will that cause a change in pressure? Yeah. So if we have a fixed volume container and the temperature is constant and we put more gas in, what does that do to the pressure? It'll increase. And if we take gas out, the pressure will decrease, right? So if we're disturbing an equilibrium in the gas state, that system can relieve the pressure change by changing the moles of gas. So here we have nitrogen and hydrogen making ammonia. So if we decrease the volume, that causes an increase in pressure. The system says, I don't like this. What can I do to lower the pressure? Well, how do you lower the pressure of a gas? You would remove some or cause there to be fewer particles, right? Because the pressure of a gas doesn't depend on what the particles are, it's just how many particles. So if we look at this chemical equation here, this has one mole of nitrogen gas, 3 moles of hydrogen gas. That's a total of 4 moles of gas. If we go to the products, we only have 2 moles of gas. And it kind of seems like an impossibility, but it's kind of like carpooling, right? Instead of taking 4 cars, let's just take 2 cars. It's going to take up less space on the freeway, right? Less space in the parking lot. So when there's pressure here and we want to reduce the pressure, the equilibrium will shift to the side that has fewer moles of gas to reduce that pressure. What if we increase the volume? That causes the pressure to go down. The equilibrium doesn't like that either, right? It's like me being very petulant. It's like, no, just can't we keep everything the same? Just, just disturbing. Anyway, so what can it do? The increase in volume causes a decrease in pressure. The system wants to replace that pressure. It needs more gas particles. So it will shift in the opposite direction because now it has 4 moles of gas and that can replace the pressure that was lost. Does that make sense? So decreasing the volume causes the reaction to shift in the direction that has fewer moles of gas particles. Now, if it's aqueous or solid or liquid, that doesn't matter, it's just gases. If we increase the volume, it causes the reaction to shift to the direction that has more moles. If the number of moles of gas particles on both sides of the chemical equation is equal, then changing the volume doesn't do anything. So let's look at this one. 2SO2 plus O2 forming 2SO3. What's the effect of decreasing the volume? So let's reason this out. Let's just talk through it in our brains. This is what I would do if I was taking an exam. Okay, if I decrease the volume, making it smaller, that causes the pressure to go up, right? If the pressure goes up, the equilibrium wants to shift to reduce that. Doesn't like what's being done to it. So here I have 2 moles plus 1 mole, right? So on the left, let's get away from the black pen. Here I have 3 moles of gas, right? And over here, I have 2 moles of gas. It doesn't matter which molecules they are, it's just number of particles for gases. So I decrease the volume, that causes an increase in pressure. I want to undo that. I want to shift to the side with more particles or fewer particles? Fewer particles. So this is going to cause a shift to the right. You'll see more SO3 being formed. What if we increase the volume? We'll shift to the left. We just answered the first one, and this is the opposite, but we should be able to think this through. Increasing the volume of the gas mixture causes the the pressure to decrease. In order to replace that, it'll shift to the side with more moles of gas.